Okay, Box and Whisker. Remember the last one? I was getting so excited for Box and Whisker, and the reason is to see what this looks like visually. I mean, viewing our data visually is very powerful. So let's say we've got heights of people, and we're going to go through this, and then we're going to go through a quick example. And we've got, remember, a whole lot of people, and they whatever heights, and we wanted to view them visually. So we wanted to say, where's the middle person? Well, we know what that is. That's our median. So we could visually draw that as our median here in the middle. And we might say, what's our shortest person? Our smallest. So like our min. So over here, we could say, well, our min person is here. Now, what this is showing is that 50% of our data is between the minimum and the median. That makes sense. Half of the data is between the minimum and the median. So just to check that we're all awake, what percentage of the data sits between the median and the max? Well, half of it. In our previous example, this was this chunk over here where we said, well, between the median and the maximum, look, half our data is lying over there. Let's get rid of that. So, okay. And then we looked at, last time we were introduced to these ideas of, let's see what happens a quarter of the way into our data. So in Q1, our lower quartile, we're a quarter way into the data. So what percentage sits between the minimum value and Q1? Well, a quarter of the data, so 25%. So here we said that here's our middle stuff. So what percentage is sitting there? Well, it's a quarter. Then we've got another quarter of the data. Then we've got another quarter of the data. And we've got our final quarter of the data. That's the point of quartiles. Quarter, right? So we've got a quarter of the data. 25% is sitting over here in this first bit, in the first quarter. Then 25%. Then 25% between, what was going to be, library, is sitting over here between the middle value and the third quartile, and then 25% of the data here. And where this is useful, and I'm going to leave this for you to interpret, because the exercise is going to go in quite nicely to interpreting the data and trying to make sense a little bit of it, is what happens if we're given this data set? The same minimum and the same maximum. But in the second data set, I know this is kind of a bit abstract, and as I said, we'll come in. What strikes you as quite different about the median? Well, the median's a whole lot further to the left. So if we had heights of people, it's like, oh, the middle person is a whole lot shorter. If we looked at this box here, let me highlight it properly like this. What percentage of the data falls within this box? Well, it's 50% of the data. So this is between Q1, between the first quarter, a quarter way into the data, and 3 quarters into our data. So half of people are here. So if you compared, if I said this was heights, then 50% of the second group would be shorter than the middle person in the first group. This is what this is saying. If you compared these two, Box and Whisker, if we had marks in a test, this would be evenly spread out. Let's say the minimum was 0 and the maximum was 100. Over here, the minimum was also 0 and 100. But most people, they got quite low. If this was 50%, they all got less than, half the class got in this range. Okay, so that's what we're going to get to, is interpreting that. And our median was way lower in this. So the middle height person is here. Okay. But you're going to get into those. I just want to kind of plant this idea of that's how we can interpret it. Okay, so let's look at this one. We're going to draw a Box and Whisker for the following data set. Now, before, what things do we need to be able to draw our Box and Whisker? Well, we need min, max. So we need the minimum, the maximum, the medium, Q1 and Q3. So let's start off with the easy ones. There's our minimum. Let's jot down what we got so far. Our minimum is 1. Our maximum on this side of the world is 24. We need to work out the median next. Well, how are we going to work out the median and what is it? Well, what is it? How are we going to work it out? What is it? Oh, I'm getting myself in a tizzy here. I was like, well, it's the middle value. How are we going to work it out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points, right? So if there's an odd number, there's definitely a nice middle value. And that middle value, 15, well, divide by 2 and round up, or add 1 and divide by 2. Either way, 15 is 7.5, so it must be the 8th value. The reason I keep pointing at my fingers is just in case you'd really forget to round up, round down. Well, if there were 5 data points, then you'd go, well, 5 of them, we know it's the third one. We can see on our fingers that it's the third one. So 5 divided by 2 is 2.5. Well, it's not the second value, it's the third, so clearly we're rounding up. So I just do that as a way of remembering if you need it. Anyone actually use that? I don't know. Let's see. So we said there are 15 points, so it must be the 8th point. So 1, 2, 3, 4, 5, 6, 7, 8 is 15, the first 15. So there's our median. So let's put here, median equals 15. And then let's work out Q1. Now remember we said to work out Q1, we had 2 different options. Are we going to work it out like that, option A, or are we going to work it out like that, option B? Now, from the last one we said neither of these is perfectly neither of them is perfect. Each has its flaws. What we're going to do is we're going to say we've accounted for this middle bit, so let's split this into 2 like this, so that we don't include that middle number on each side. And now we're going to look at Q1 and go, well, 1, 2, 3, 4, 5, 6, 7 conveniently has an odd number. So we're going to pick out this middle bit and say that Q1 equals 8. And on the right-hand side, we've got same idea. Q3 sits in the middle of that. Q3 is 20. Now, I'd really just want to reinforce this point. There's no magic one to say this one's definitely better than the other. There's some lovely articles. So if you really want one, please ask. I can pass one on from Learning and Teaching Mathematics. And yeah, that's it. Okay, so now the last part of the puzzle is not to insert an image, is to draw this. Now, we need to draw this to scale. So we start off, we draw our number line. We know that it's going to go from 1 up to 24. So let's maybe say we've got, maybe this was 0. This is 26. And let's count them up in 2s. So I don't know if I'm going to get this right. It would be helpful to use a ruler and go, well, that was like 10 centimeters, so let's vaguely get it right. But let's see how close I get. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 is there. So I'm going to redraw this because it does need to be to scale. So that's fine if I get rid of that line and just redraw it. Really, the scale is important because we're using our scale to make some calls here. Okay, then once we got that, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Then we can just draw our things above that. So we've got our minimum was 1. There it is. Our maximum was 24. There it is. Our median was or is 15. There it is. What do we have? Q1 is 8 over there, and Q3 is 20. So that's going to be over there. This middle bit here, we drew as a box. And then we drew these things out. And you get asked questions now like, is the data skewed one way or the other? This one I'd say is pretty even. Look, there's the middle, kind of in the middle, seems to break up nicely into quarters. So enjoy working with these. And that's that for now.